Hello, Professor Yamoka. I am in your 4720 class. My name is Benjamin Rojewski. I wasn't able to attend the normal lab time due to the conference championships for Oakland Swim and Dive. So this is my virtual turn-in of the second laboratory. I'm sorry that it's so late uh, in general and with the day, the actual time. But without further ado, here we go. So I just want to preface this by saying I actually never got it working. For some reason, in the second addsub, which is this one here, where it adds the LZD output with the unsigned exponent, it has a proper x, it has a proper y, it's told to add them, and it adds the first one correctly, adds the second one correctly, adds the third one correctly, but when it gets to the fourth bit, it just gets an undefined. It's not even in the carry. I really don't understand why it does this. I tried going into the full adders just to see if there's anything that could tell me. And you can see here that the S value of the third full adder of the second add subtractor, it just never initializes. I really can't tell if this is my code or not, but with this bug, I'm unable to test to see if everything's working correctly, as with this final example, the one that is the closest, but it's still off. As you can see, if I hover over it, it says 5U, so part of that is still undefined. But only the first two, the first hex is wrong, because it should be 3C1, C0000, as you can see here. But it's 5C1, C0000. So something with that second add subtractor is wrong, but as far as I can tell, it's not my code. Without further ado, here's my code for the top file. You can see here I initialized the addsub as a component, as well as set the A, B, and M as my port URL. I have the LZD as a component. I have the barrel shift as a component. And then onto the signals. I modeled this after the model right here. We have the first two sign bits. We have the exponent bits, and we have the actual, I forget the name of it, but the other bits. Here in the middle, we can see all the other signals we calculate. EP, I call this one S, and then this one PM. And then in order to truncate it, I go ahead and call that one PM2. So PM2 is the truncated value. We got the direction, we got it going into the LZD. In order to get the LZD working, I needed the signal out of the LZD. That is 4 bits, so I need to extend that, which changes it to 8 bits, which we can add correctly with the second add sub. And for the record, those values are correct. Like, this is an initialized X, and then this is also initialized Y. I still don't understand why the third full adder in the second add sub is just not initializing, but I can guarantee you that they're at least getting values. And then all the other miscellaneous signals in here. And then finally out, S, G, E, F, just like all the signals. Here I pull the very front of the number, the most significant bit, both, and then XOR them, and then that's just that one on the left. Here we have some miscellaneous signals. They're kind of tied together with the designation of the components. So I'll just do what I can here and then add on what I can when I get to that part. So here we have the first exponent from 30 down to 23. That should be 8 for the exponent, 8 bits for the exponent. We do that with A and B. Then I take EP, and EP should be 9 bits. So instead, I guess I'll just go right now. What I do is I add E1 and E2, so the exponent of A and exponent of B, and I actually take the carryout, and then I take the carryout and I add it onto the front of the EP value. So I have to use a temporary value for the output there, and then I get my correct EP value by concatenating, I think the word is, C and EP temp. From there we go to the, we have the bias, which is 127 in binary, and then finally E is just lopping off that final bit, the most significant bit. Here we have the value coming out of the LCD as well as the direction, and okay, yeah. And here we go, the floating. I wish I remember what this is called. The rest of the bits, the 1 point something number. The original F1, F2, designate the last 23 bits. Then I go ahead and add a 1 on the front of those, concatenate it with 1. Go ahead and multiply that, assuming it's an unsigned number, at the top here. And then finally, you have to truncate that value because it's way too big for the barrel shifter. And then when I finally do get my value, I just turn it to F from the shifter. Here's my components. Here's the first adder subtractor. It's set to add exponent 1, exponent 2, output the temporary AP that is 8 bits and the final bit, which I then concatenate together to get my final EP. Here we have my second add subtractor. I've set it to 9, and it will follow the rules of the inverse of direction, which I define right there. Not direction is equal to, or is set to not dir. I go ahead and then set X to EP as is listed, Y as the out signal of the LCD. But in order to do that, I had to sign extend it. Here you can see the code for that. Just append a bunch of zeros there. And S is the EX value, and then C out, I just wrote a C temp for a temporary, just to see if that would fix the bug with addsub 2. Again, something here is going wrong, and I don't understand it. And finally, we have the bias. It basically same as before, except it's always subtracting. And it subtracts the bias from EX and outputs it to what I call EB, which is E plus 1. And then here you can see how I truncate that. And then finally, I concatenate all these together to get my final answer of M. And just to go back to the waveform, these final answers are close. Here we can see EUB, and you're looking for C5B. So again, it's just off by a little bit. For some reason, when we get into these ones, again, it's only off by a little bit. Those two left hex. Here, it's just the first two aren't even defined. And again, it's something to do with the second add sub. Here we can even see it. It's only the third bit. Again, something to do with the third full adder. I really don't understand it. But as far as I can tell, this is as far as I got with the bugs I had. If you have any guidance or any suggestions on what I can do to bug fix, please let me know. But in the meantime, I believe this is as far as I can get with how I understand it currently. Thank you so much for your time. Sorry if that was a little bit long. I've been working on this most of the day, and I actually got back from the competition at 6 a.m. today, so I didn't get to sleep since we left at 12 o'clock at night, and it was a 6-hour bus ride. So I thank you for your time, and I hope it's not too late for you to respond. Thank you very much.